Non-directional beacon. An NDB is an omnidirectional ground-based navigation facility utilising an instrument known as an automatic direction finder on the flight deck, producing great circles for the pilot to fly. The frequency band is 190 to 1750 kHz, utilising vertically polarised ground waves. NDB Emission Characteristics. There are two main types of emission characteristics of an NDB. Non-A2A produces an uninterrupted carrier wave and is identified by an AM tone. In simple terms, this means that there is no loss of the signal during identification and is shown with an asterisk next to the facility, certainly in the UK. The non-A1A NDB produces an unmodulated carrier wave and has a degrading signal during identification. It requires the use of a beat frequency oscillator. An underline is shown below the NavAid identifier. It indicates the beat frequency oscillator is required to hear Morse code identification. NDB emission characteristics. Type, locator, is 15 watts, and these are used on final approach 10 to 25 nautical miles. The example is the non-A2A. Low power, 200 watts, are used for holding and en route for ranges up to 50 nautical miles, also non-A2A. These are the ones that are primarily used in the United Kingdom. Long-range ones are 5 kilowatts. They are used for en route greater than 50 nautical miles and are known as the non-A1A. What affects an NDB? Frequency. The lower the frequency, the less attenuation, and therefore a greater range. Power. Range is proportional to the square root of the power. So to double the range, the power must be increased by a factor of 4. Static. The signal is attenuated through a moist atmosphere or totally lost through a cumulonimbus cloud. NDBs cannot be used at night due to skywave interference at the ionosphere. They have a signal-to-noise ratio of 3 to 1 during the day internationally and 5 to 1 in the UK. NDBs utilise what is known as a cardioid, heart-shaped polar diagram, with a single null and have an accuracy of plus or minus 5 degrees, day only. So in summary, the errors of an NDB are static, station interference, quadrantal error, night effect, mounting effect, and coastal refraction. The average allocated range of an NDB is 15 to 30 nautical miles. ADF Airborne equipment. The beat frequency oscillator permits an unmodulated transmission to be heard, and therefore it must be on for ident for a non-A1A in manual and automatic mode type of NDB. For a non-A2A NDB, the beat frequency oscillator is only required if manual bearings need to be obtained and is seldom, if at all, used. Information is displayed once selected on a relative bearing indicator or on a radiomagnetic indicator. The RBI, relative bearing indicator. The picture opposite shows the direction of the NDB beacon relative to the fore and aft axis of the aircraft. The bearing shown is magnetic and needs to be converted into true. In order to do this, apply variation at the aircraft. In the picture, the relative bearing is 315 at the head of the needle. RMI, the radiomagnetic indicator. Two magnetic bearings can be displayed on an RMI by either two NDB frequencies or an NDB and a VOR, or even a VOR and a VOR. The display still shows magnetic bearing and variation has to be applied at the aircraft. If there is a failure of the RMI or RBI, a flag will appear to signify that the frequency should not be used. In this example, the ADF bearing of 300 from is directly shown at the end of the single line needle. The VOR bearing is 015 from at the end of the double line needle. Plotting position using an NDB. Example: an NDB is located at 60 degrees north, 3 degrees east. An aeroplane at a dead reckoning position of 60 degrees north, 3 degrees west, where variation is 2 degrees west, obtains an RMI bearing of 0.75 magnetic. What bearing should be plotted on a Lambert chart? You can see from this diagram that the meridians slope inwards towards the nearer pole. A transferred meridian can be placed at the NDB position from which the bearing should be accurately drawn. This will now include Earth convergency. So, convert the measured bearing to true. Since the bearing is measured at the aeroplane, we must apply that variation. The RMI is reading 0.75 magnetic and variation is 2 degrees west. So the true bearing is 0.73 true. Convergence is 6 degrees. That was the difference in longitude from 3 degrees west and 3 degrees east. And the latitude was 60 degrees north. So take the sine of that and get an approximate answer of 5 degrees of convergency. The reciprocal bearing will be 0.73 plus or minus 180 degrees, which is 253. Add the convergency of 5 degrees that you just calculated, and you'll be able to plot 258 true. The range over land in nautical miles is 2 times the square root of the power in watts. The range over water in nautical miles is 3 times the square root of the power in watts.